In this exciting tutorial, we will be coding our own TensorFlow image classification model in Python, specifically a convolutional neural network for fruit classification. And then in the next tutorial, we'll actually deploy our neural network model that we coded in an Android app for image classification. Please give the video a like and subscribe if you find it helpful. There's a lot of fun ahead, so let's get started. We're going to be writing all of our code in Google Colab, so we can go ahead and search for Google Colab and visit the website. Colab provides us with free Jupyter Notebook environments that run entirely in the cloud, and they even provide us with GPU instances so that we can make our training faster. I'm going to go ahead and click on New Notebook to create a new notebook, and now I have a place where I can write some code. I'm going to call this notebook Fruit Classification TensorFlow Model for Android app. The first thing that we're going to have to do is get our data set of fruit images, specifically apples, oranges, and bananas, into our Google Colab. Fortunately, I made all of this easy. All we have to do is use the wget command, so type !wget. And if you go to the video description, I provided a link to this Bitbucket fruits zip file where it contains our data set. So running this command by clicking the run button over here will allow us to have our dataset downloaded into Google Colab. That way we don't have to upload it or do anything like that. And once again, this link is in the video description to make it easy. And as always, all the code for this tutorial, both the starter code as well as the complete and finished app, is provided in the video description. If you find the repositories useful, please make sure to give it a star. And now you can see that it's downloaded our zip file, which contains our dataset, fruits.zip. And if we go over to the files section over here, you can see we have fruits.zip over here. The next step is to actually unzip this data set. That way we can take a look at the images inside. So once again, we're going to type unzip and fruits.zip. And you can press the run button over here or hold shift and press enter. And this will run the cell. You can see that it's unzipping all of these files. And soon over here, once we press the refresh button, this refresh button here, you can see that we have a fruits folder. Inside of this fruits folder, I've already prepared the data set for us. So we have training, testing, and validation folders for our neural network. About 70% of the images for apples, bananas, and oranges are in the training folder. And we can go ahead and look at how this is organized. Inside our training folder, we have apple folder, and then we can click on these images to see pictures of apples. So this is how our data set is organized. Similarly, if I go inside the test folder, we again have apple, banana, and orange folders. Inside the orange folder, we have some images, and this is what our data set looks like. So now that we have our data set prepared, or at least the folders organized, we're ready to go ahead and start doing our imports. The first thing that we're going to do is import TensorFlow as TF. And we're also going to import matplotlib, which will allow us to view our images inside our actual notebook rather than going to the folder over here. And I'm going to import this as PLT, that way we don't have to do as much typing. I'm also going to import, I think this is good for now, so we'll go ahead and run this cell. And now I'm going to use this function tf.keras.utils.image dataset from directory to load these images into a variable that we can use for training our models. So first I'm going to start by creating a variable for our training folder, and inside over here, inside of this function, I have to provide some parameters. The first parameter I'm going to provide is the path to our training folder, because what I want to do is load all of these images inside our training folder into this variable here. And that's why I'm going to provide fruits/train as the path. I also have to provide the image size. So I'm going to go ahead and create some variables for my image height and image width. Image height and image width. We're going to have these images, whatever, right now they're in all sorts of different sizes. We want to resize all of them into 32 by 32 images that are all the same, so our neural network can train on the images of the same input size and dimension. So now that I've provided the width and height over here, I'm going to type image underscore size equals image height, comma image width. And for my next parameter, I can specify the batch size. So this is how many images that our neural network will train on before it updates its parameters. And I'll just specify 20 for the batch size for right now. So I'll say batch size equals batch size. And now I have my variable for my training data set. So let's go ahead and run this and see what happens. So you can see it said that it found 460 files belonging to 3 classes. Our 3 classes are the apple, banana, and orange. And if you were to count all the number of images in each of these folders for apple, banana, and orange, it would be 460. Let's go ahead and do the same exact things for our validation set as well as our test set. So I'm going to copy and paste this. I'm going to rename these variables valid ds, or I'll call it val underscore ds and test underscore ds. We got to change the path. So fruit slash validation for valds and fruit slash test for test ds. Now let's run this and see what happens. So you can see it's printed out 3 lines. On the first line, printed out 460 files belonging to 3 classes. That's for our training set. Next, it printed out 66 files belonging to 3 classes. That's for our validation set. And finally, 130 files belonging to 3 classes for our test set. And if you're new to machine learning, typically what this means is that our machine learning model is going to train on our training data set. And while it's training on these images, it's learning from these images, we're going to evaluate it on our validation set. And this is basically to see how our neural network does on images it hasn't seen before while it's going through the training process. And finally, we're going to evaluate our models. Once our model is completely trained, we're going to evaluate it on our test set. So that's why we have these 3 different data sets, approximately 70% for training, 10% for validation, and 20% for our testing. So enough talking, let's go ahead and take a look at what our images look like. So I'm going to create an array for my class names. First off, we have apple, then we have banana, and then we have orange. And using the matplotlib Python library, PLT, what we're going to do is create a figure, and I'll say fig size equals 10, 10. Now what we're going to do is we're going to iterate over some images. We're going to take, in order to actually get a batch of images from our training data set, so remember our batch size is 20. In order to get a batch of 20 images, what we're going to do is say train ds.take 1. And we can actually iterate over this. So I'm going to say for images, comma labels in train ds.take 1. And this is going to give me a list of images and a list of their corresponding labels. So what folder they belong to. I'm going to display 9 of them in a 3x3 grid. So that's what I'm going to say for I in range 9. AX equals plt.subplot 3, 3, I plus 1. And now to actually show the image, I'm going to use plt.imShow, that function. And we have our images list over here, so I'm going to say images of I. Then I'm going to make it get a numpy array from that and say as type uint 8. I'm also going to provide a title for each of these images. So this is actually displaying the image, but let's provide a title as well. Let's display the name of the fruit above the image. So that's what we're going to say plt.title. We have our class names array over here, so I'm going to say class names. And then labels is a list of the labels. It's a list of 0, 1, and zeros, 1s, and 2s, telling us what fruit this is. So that's what I'm going to say class names of labels of I. And I can just say plt.axis off. And now when we run this, there we go. You can see that it's displaying a 3x3 grid of 9 fruits, and that's pretty cool. We can see oranges, bananas, and even though all these images started off at different sizes, we've rescaled them to 32 by 32 images. So you can go ahead and run this cell a couple of times if you want to see what the dataset looks like. You can see that it's displaying different images now. Now that we have our data set ready to go, the next step is to create our model. So I'm going to create a variable called model, and then I'm going to say tf.keras.sequential. And what this allows us to do is add layers to our neural network. And we can provide a list of layers. So that's why I'm going to type parentheses followed by square brackets. And inside over here is where I can start providing my layers. But the first thing that we want to do is actually a bit of pre-processing. Right now, we have these images, and each of these pixel values for R, G, and B go from 0 to 255. We're going to rescale that to be between 0 to 1. That way there's a smaller range of values for our network to learn. So that's what I'm going to say tf.keras.layers.rescaling 1 point and then divided by 255, and this will handle doing all of that division for us. So once again, what we'll do is we'll go through each of these pixels and divide it by 255. So instead of being from 0 to 255, it'll be from 0 to 1, and this is our basic pre-processing layer. Then now we're actually ready to start adding the main layers of our neural network. The first layer that we're going to add is a convolutional layer. And if you're unfamiliar with convolutional neural networks, I'll provide a link in the video description where you can read more about them, because the focus of this tutorial is how to create a machine learning model in Python and then use it in your Android app. But essentially what the convolutional layer does is apply filters to images to learn certain features. And in this case, I'm going to have it apply 32 filters with a kernel size of 3 by 3. And my activation is going to be the ReLU. Our model is going to have several convolutional layers that we can learn to extract features and distinguish between apples, oranges, and bananas. In between these convolutional layers, we're going to have max pooling 2D layers. And what these will do is it'll downsample the size of these feature maps. Specifically, the max pooling 2D layer looks at every 2 by 2 patch of pixels in our image or in our feature map, and it takes the largest of those pixel values, and that's what's going to be chosen. So essentially it's cutting down our feature map size by 4 times. Each dimension is being cut down by half. So we're going to have this convolutional layer here, our pooling layer. And let's just go ahead and copy this a couple of times. That way we can have 3 convolutional layers. What these convolutional layers do, I forgot to mention, is they also allow our model to do this learning process while retaining the 2D structure of these images. So right now, these images are still in that 2D structure, 3D if you want to count the number of feature maps. And after having learned these features from the convolutional layers, we're going to flatten out all of these inputs in our model. So that's what we're going to use the flatten layer. So now it's one dimensional. And with the flatten layer, after flattening it out, we're going to create a layer. So tf.keras.layers that is dense or just has neurons. It's going to have 128 neurons. And once again, we're going to use the ReLU activation function. And finally, after having these 128 neurons, in our last layer, we're going to have the number of classes that our model is trying to classify, which in our case is going to be 3. So this is what our neural network will look like. It's a basic neural network. You can make it more complex and play around with it if you want, but essentially, to recap, we have this rescaling layer to pre-process our images and get it to be, each pixel to be from 0 to 1. We have 3 convolutional layers and 3 max pooling layers that retain that 2D structure, learn features, and downsample the feature maps. Then we flatten it all out, have a dense layer with 128 neurons, and finally our last layer in the neural network has 3 neurons, 1 for each of the classes. So let's run this cell, and now we have to compile our model. We have to compile it with an optimizer, so I'm going to use the Atom optimizer. The way that neural networks work is as they're learning, they're trying to minimize a loss function. The loss function that we're going to choose is, because we have 3 neurons in our last layer, we're going to use a loss function called sparse categorical cross entropy. So I'm going to type tf.losses, and then the loss I want is sparse categorical cross entropy, and I'm going to say from logits equals true. And in addition to computing this loss at after every epoch or iteration over our data set, I also want our while our model is training, I also want to receive the accuracy. So that's where I'm going to add another parameter here called metrics. Inside the square brackets, we can provide a list of metrics we want our neural network to calculate while it's training, and I'm going to specify accuracy. We are ready to compile our neural network. Everything's good. After a model is compiled, we're actually ready to train it. So the way that we do that is by using the fit function. So model.fit, we're going to fit it or train it on our data. So remember we have that variable train ds. I'm just going to scroll up really quickly. Remember train ds contains all of our images from the fruits and then training folder, which is about 460 images. So model.fit train ds. I'm also going to provide it with validation data. So it's not going to learn from this data. Instead, it's going to be evaluated on this validation data. That way we can see how it does on this data set while it is learning. So we can say val ds. And for the number of epochs or iteration over our data set, I'll specify 10. So it'll go over this whole data set, over the whole training data set 10 times and learn from those images. So let's go ahead and run this and let's see our neural network learn. So you can say epoch 1 out of 10. It has an accuracy of 59.13% on the training set. This is the accuracy over here on the validation set. You can also see that our validation loss is decreasing. Once again, our loss function is the sparse categorical cross entropy. And one thing that can help you help this code run faster is if you go to runtime, over here in the menu, select change runtime type. And I should have selected GPU accelerator from the beginning. This would have made the whole training process faster. Unfortunately, I forgot to do that. So if it's not too late for you, I would select GPU, click save, and it would just make this whole process faster. But now you can see that our model has finally finished training. Its validation loss increased a little bit, but now it finished at 0.10. And we have an accuracy of 97.83% on the training set and 96.97% on a validation set. So it looks like our model hasn't overfit too much on the data set, which means that it's like pretty much memorized what the training data set looks like. And this is great. These are great results, great accuracy for a fairly basic convolutional neural network. Let's go ahead and evaluate our convolutional neural network now on the test set. So it's never seen these images before. It hasn't trained on them. It hasn't been evaluated on any of these images. Let's go ahead and see how it does. So we'll type model.evaluate, and inside we'll pass in our test dataset variable, which contains all of our test images. Let's run this. A 93.85% accuracy. That's pretty good. Let's see how many images we had. We had 130 images, so it was able to, out of 130 images, it correctly classified 93.85% of them. Now that we have a fully trained model, the last thing that I'm going to show you is how to actually use it to make predictions on images and receive those predictions. So over here I've copied some code that we had earlier. All this does is it's going to take one batch from our test data set and get us the image and labels from the test data set. And all that we have to do to get a prediction from our model is just say model and pass in the list of images. So in our case, we passed in a list of 20 images to our models. We got the classifications, and you can see that I'm printing it out. For every single image that it needs to predict, it's going to give us an array of size 3. And the array tells us the likelihood that it's an apple, a banana, and then an orange. And the index with the largest number is what our model thinks that that image is. So in this case, this first image had the biggest number, 4.04, so it thought the first image was an apple. Over here, it thought the second image was going to be an orange. It also thought the third image was going to be an orange. And the reason for this is because if you look at our neural network, the last layer is a dense layer with 3 neurons. So that's why we're getting 3 outputs, the likelihood of it being an apple, banana, and orange. And now I've copied over this code that's going to display the images in a 3x3 grid along with their predictions and actual labels. And this is really cool. You can see that our model thought that this was an apple and it actually was an apple. It thought that this was an orange and it actually was an orange. And the way that this works is once again, we're feeding these images into our model and getting the classifications. NumPy is a library that provides a function called argmax that basically gives us the index with the biggest number. And remember, our classifications has that array of size 3 with the likelihoods. So that's why we're using numpy.argmax to get the index with the biggest likelihood. And then all we're doing is just printing that out. So to conclude, in this tutorial, you learned how to create your own convolutional neural network in Python for image classification, specifically for classifying between apples, bananas, and oranges. In the next tutorial, we're going to go ahead and actually take this neural network that we coded over here in Python, and we're going to deploy it in an Android app. That way users can actually take pictures on their phone or upload pictures and have the neural network running on their phone identify this as an apple, an orange, or a banana. There's a lot of exciting stuff ahead, so please make sure to subscribe and get notified when that tutorial comes out. I put a lot of effort into these tutorials, so please make sure to give them a like and share them with friends. As always, both the code to get you started with this tutorial and the code for the complete finished app will be linked in the video description. Until the next tutorial, happy developing from IJ Apps. I hope to see you there.